late आया था मेरा फिर ड्रामा हो गया.
Hello mathematicians, I am Tanisha Tyagi from S. Chand Publishing and I am delighted to welcome you all to the second session. Am I audible? Preeti, if you can check if I'm audible.
Yeah, yes.
Okay. Great. Hello mathematicians, I am Tanisha Tyagi from S. Chand Publishing and I'm super excited to welcome you all to the grand finale of the Mathematics Summit 2.0. We have had an amazing time together so far, learning from some of the brightest minds in mathematics. But now it's time to turn up the heat and make this final session one for the history books. So get ready to get excited, get engaged, and get inspired. Let's make this the best finale ever. In this session, we will explore the intriguing topic of what could a math week look like, presented by our distinguished speaker, Mr. Mark Hansen. Mr. Hansen, an Australian educator and author, is passionate about promoting mathematics education. He has been involved in education for nearly 2 decades, serving as a classroom teacher, master teacher of mathematics, and deputy principal. He is also the father of 4 children. Mr. Hansen's work has been featured in educational journals, and he is the author of 2 internationally published children's books promoting mathematics, Math for All and My Garden is a Square. His goal for schools and societies is to have confident students and creative communicators in mathematics who see its purpose and enjoy engaging with it. We have also pasted the link to his books in the chat box for your convenience. So now, before we begin, I would like to review a few housekeeping rules for the session. Participants will be muted throughout the entire session. Please ensure you have a pen and paper to note important information. The chat box will be enabled during the Q&A round or as and when required by the speaker. To receive your e-certificates, please fill out the feedback form that will be sent to your registered email IDs after the summit. Don't forget that we have an exciting quiz planned at the end of the session with a prize pool of Amazon vouchers worth up to Rs 24,000. The quiz link will be shared in the chat box at the end of the session. To participate, please fill out the Google form. The form will be active until 11:59 p.m. on August 27. And we will also be picking up 3 lucky participants for the lucky draw with a grand prize of Rs 15,000. The quiz and the lucky draw winners will be announced by next week. So now, without further ado, let's welcome Mr. Hansen to take the word to the floor. Over to you, sir.
Wow, what an introduction. Thank you so much, Tanisha, and thank you to the organisers of this great conference. It's a pleasure to be with you all the way from Australia. So it's about 8:30 at night our time. I understand it's the afternoon there, so namaste, and I hope your day's been going well. And as I said, it's a privilege to be here this afternoon for you, and I look forward to sharing a few little tips that I've learnt along the way. It'll be a somewhat interactive session, but I'm keen to have a bit of feedback as well through the chat box as we get into it, and we'll just go through and see what we can learn together. I'm happy to keep in touch afterwards. So if you've got anything that you'd like to ask me, the contact details will be provided for you, or you can look me up and I'd be happy to take any questions from you. And I would like to thank you very much for coming to today's session. So without further ado, I'll share my screen. Yeah, so good afternoon. And as I said at the start, and as Tanisha said, this session is all about what a maths week could look like. And that word could is important. It's not saying that this is what a maths week should look like. It's not saying this is what a maths week must look like. It's just trying to give you some ideas as to how maybe you could structure your maths lessons for a bit more impact. Some of the things I'll be sharing, I've learned along the way. They're engaging activities. We want them to be research-based, so we don't want children just having, going through little activities that they're finding enjoyable. We want them to be learning mathematics as well as it being enjoyable. So I think that's part of the challenge as a maths teacher. So our goals today are basically I'll give some background context about where I'm from, why you should even be listening to me, maybe, but then share maybe, like I said, a weekly timetable, and we might even practice some activities that we've been speaking about. But a lot of these activities are not my own. So as it says down the bottom right there, all credit goes to those people who have created some of this, and credit has been given wherever possible for that. So thank you, and let's get into it. So as Tanisha said at the start, my name is Mark Hansen. I enjoy sharing mathematical resources. I do it because I love it. If you can let me know about yourself, perhaps in the chat box, you can just tell me maybe your name, what your role is, whether it's a teacher or maybe a parent or someone who's trying to make an impact, maybe a tutor, someone who's trying to help students, and just even how you're feeling at the moment, whether you're excited or looking forward to the conference or something like that. That'd be lovely. For myself personally, like I said, I'm feeling confident and excited, privileged to be here today. And my background is as a classroom teacher. In 2015, I was a master teacher in Queensland, selected for that, one of only a couple of hundred who was selected from across the state for that. And then in the last 5 or so years, I've been a deputy principal at a school. So I think I've got a fairly good range of experiences in terms of being able to see how schools run, what's actually possible within school structures. I mean, what I'm sharing is, of course, from an Australian perspective, but I hope that it's useful to you wherever you are. So to kick us off today, we'll do one of these activities. Now, if you're not sure what this is a great little maths activity you can use with your class. You can use, there's many ways you can tailor this for your class. It's called Which One Doesn't Belong? And the idea behind it is that you put this up at the start of a lesson, maybe, just to get some maths conversations happening, to get some discussions happening. It's a nice one to get students into mathematics as well, because there is no set answer. So often with mathematics, some of the anxiety for children in particular and adults comes with thinking they must get the answer right. And so we confront this activity by saying, boys and girls, there's no right answer, there's no wrong answer. And so in the chat box, if you like, you could just tell me which one of these numbers do you think is different? Is it the 9, the 16, the 25?
Many of the participants have mentioned 43. Many
Excellent.
of the participants
Okay, so
in the chat. Yeah.
Fantastic. Thank you, Tanisha. So what we're after from there is the reasoning behind it. So if a student said to me, oh, sir, 43, I'd say, excellent. Why did you choose that answer? Likewise, if they said 9, I'd say, excellent. Why did you choose that answer? So I guess in the chat box, if you like, you could justify that. We're looking for that mathematical language, which, as we know, is part of the national curriculum framework in India. Part of the national curriculum in Australia is about that reasoning, proving your answer, those types of things. So you can even say to students, oh, really? You chose 43? That's great. I chose the answer 9. Why do you think I chose the answer 9? So again, you're putting it back to them. If a student isn't sure, you could say, that's okay. We can do a question relay. So that student can then ask another student and say, I'd like to listen to Joan's answer. Joan then gives her answer. And then you come back to that student and say, why do you think what did Joan say? And put that in your own words. So is there anyone there who's got a reason why, Tanisha?
Yes, many of them have mentioned 43 is not a perfect square. And few of them have mentioned like 9 is a single digit number, rest are not. So they have answered 9.
Fantastic.
Yeah.
Yeah, I mean, you could even say 16. It's the only even number. So there's the quality of this question, I guess, is dependent, and the quality of this discussion is dependent upon the quality of the numbers that you choose, what you put up there. I've seen other people even do shapes. So you could put up a triangle, a rectangle, a square, and a circle, say, and students have to identify which one is different. Again, just to emphasize, there's no right or wrong answer at all. And I think that that's really critical, because what it means is that students can get into this question and they're not worried about whether they're going to be wrong. No matter what this child says, we're going to validate that answer, and then it gives us an idea of where they're at with the mathematical answer. I mean, for the people among you who mentioned 43 isn't square, that tells me a lot about where you're at with your mathematics, that you know what a square number is. And not only that, but you can work out what isn't a square number. So when you're doing, no matter what their focus is, you could be doing fractions. So that's a really great little activity just to kick us off today. Thank you for participating. I hope you enjoyed that little activity. So what we don't want in mathematics time is this.
Since our first equation tells us that y equals 3x plus 2, this means that we can substitute a 3x plus 2 in for the y in our second equation. In other words, since y means the same thing as 3x plus 2, we can replace the y in the second equation with a 3x plus 2. And rewriting our second equation, we now have 7x minus 4 times.
So I'm not suggesting that any of our classrooms look like that. Maybe mine did in my early days of teaching, but we don't want to be putting the students to sleep. We want them engaged. As it says there, 62% of maths teachers say that working with unmotivated students is one of the hardest parts, one of the most challenging parts about being a maths teacher. So we want to make sure that our lessons are engaging, and like I said, that the students are learning as well. So in Australia, we've had these sorts of headlines in the newspaper over the last few years. Things like maths must change, experts push for more problem solving. Then another one, the proposed new maths curriculum doesn't dumb down the content, it actually demands more. There's a lot at stake as the maths wars erupt, and then maths wars, the great divide. For those unaware, and it's a similar situation that's been happening in India over the last few years, I understand. It's basically the idea of that explicit or direct teaching pitted against that sort of constructivist, more progressive perhaps style of teaching, where it's more student-led. The students get more say over what's happening, and it's more that their understanding goes through that rather than the teacher being at the front saying what is happening. It's a little bit like literacy, where we've sort of had the phonics wars, where it's like whole language approach or the phonics sound. I'm not necessarily going to say that I'm one way or the other on this debate. I would actually say that the answer is somewhere in the middle. There's certainly a place for explicit teaching and direct teaching. There's certainly a place for students to learn fluency and to learn things like their times tables and things like that. But also there's a place for, in the Australian curriculum, it calls it fluency and understanding on one side and problem solving and reasoning on the other side. So I think that that's really important to understand. This is for those, I mean, I understand none of you are in Australia at the moment, but just my background, these are some of the aims of our curriculum. It talks about things like students being confident, creative users and communicators. It talks about them interpreting situations. It talks about a sophisticated understanding. It talks about being able to pose and solve problems and reason. So some of those things that we've already done with that which one doesn't belong, you can see that some of those things, we've already done those just with that little activity. The ones that are highlighted there and bolded there are the ones that I feel are really hard to achieve if all we're doing is standing at the front of the classroom and direct teaching to students. So we might still have confident students. We might still be able to have students who are investigating and representing. We might still have some of those other types of things, but it's going to be really hard for students to do things like recognize connections, be creative communicators of mathematics. So for those things to happen, there's going to have to be a bit of a shift in how some classrooms operate. From my understanding, the National Curriculum Framework in India, it says these types of aims. So develop things like finding patterns, making conjectures, justification with logical reasoning. So you can see some of the similarities there between the Indian curriculum and the Australian curriculum. It talks about creativity, it talks about problem solving, and it talks about clear communication, and it says both oral and written. So those sorts of discussions that need to happen in maths classrooms. It also says, and that I found down there, the countering the fear of mathematics will require a shift in teaching learning methods towards play-based, activity-based, discovery-based, and discussion-based learning. So they're the sorts of activities I'll be sharing with you tonight. And I guess your role is to think about which ones do you think are useful. If you can walk away full of ideas and then way to make that a bit more of a habit in your classroom and make it sustainable in your classroom, that's what we want. We don't necessarily want you thinking, oh, okay, I'll do that one activity and then just sort of forget about it. So we'll talk a bit about that. And it also says when taught well, mathematics is truly enjoyable and can become a lifelong passion. And we want to bring mathematics to life. And that's a challenge in the classroom. It's a challenge everywhere, but particularly in a classroom, which is a fairly artificial environment. A school classroom is not necessarily like the real world. We're not necessarily doing the sorts of things that we do in the real world. We're not going to the shop. We're not buying dinner at restaurants. That's the sort of things that require us to use mathematics. So our job as teachers is to try and bring that real world into the classroom as much as possible. So we know, this is what we maybe know as teachers, that a change from lecture rote style to more play-based is probably what we should be doing. One of the challenges for us is that we've got timetables. We're busy. You know, there's a lot that we need to get through. We might have systemic requirements. So the school might be asking us that we do certain things at certain times. We might have some resourcing or budget requirements. So these activities won't require any resources or budgets really. And also we think, oh, we can't just do open-ended questions or all these sorts of questions because the classroom would be a mess. We've got so many students who've got different abilities. How can we do these questions if they've all got different abilities? So that's a challenge for us. What we really want is to feel confident and in control of our time and direction. We want to have the support of our school and administration team. And we want to make sure that we develop a classroom where our students feel safe and confident to share. So that's what sort of kicks us off today. So with that in mind, I propose this type of timetable in the classrooms over there. I'm not sure how long your maths classes normally go for, but in Australia, what we often find is that in the English time, which might be an hour and a half, our teachers are very structured with what they do in that time. So they might have their spelling time, they might have their writing time, they might have their reading time, they might have their group time. They have all that structured out for their day, and they don't necessarily change that too much week to week. That's kind of a locked-in timetable. What I've found is that in mathematics, our teachers don't necessarily do that. So what I propose is thinking about your maths time as cutting it into little pieces and thinking about how can I fit these pieces into my maths week. So as you'll see from the timetable, there's still a place for explicit or direct teaching. So there's still going to be some time when you will go in and you'll basically tell the students how you want them to set something out, or it might be practicing times tables, things like that. But it's not going to be necessarily all the time. And again, this session is called What a Maths Week Could Look Like. So we already know what explicit teaching looks like. We're not going to spend too much time on that today. We're just going to look at some of these other sections. So you can see from this image, we've got things like warm-ups, number talks, open-ended questions, and we want to try and think about those types of things and maybe story-based learning and think about, well, what are they? How could they help our students? And are they worth putting into your timetable? So let's have a look at some of these activities. The first one we're going to look at is a warm-up. So a warm-up is basically like a little activity. You might hear it called an activation task or an activator. It's just going to get the students excited about mathematics, get them into the session. The which one doesn't belong that we looked at to start the session is one of those activities. It's something that the students could just start straight away and get into. And that's what we want from a warm-up. They generally are fairly short. They might go for 10, 15 minutes. Your aim in this session is to validate all answers, make the students feel included, listen and respond, make connections between student answers, and help the students feel safe sharing their answers. So this is one little warm-up that you could use. It's called Two Truths, One Lie. And the statement is, these are triangles. So again, in the chat box, if you like, if we call it maybe say shape A, B, or C, which one do you think is not a triangle? Because one of these statements is a lie. They're not all triangles. Which one is not a triangle? A, B, or C? And again, like that first activity, why? Why do you think that that one is not a triangle? So if, you can relay some of those responses, Tanisha, when they come through, please.
Sure, Mark. Like I can see in the chat box, there are like participants have mentioned the third, the C, like this. It's the answer, I guess, and they have mentioned because it's not open, it is not closed. Sorry, yeah, it's open, it is not closed. Polygon, closed triangle, like that. It's
Yeah,
not a closed
great,
polygon, right?
perfect. Yeah, thanks, Tanisha. So again, this one does have an answer. It's different to that other. Which one doesn't belong? This one's two truths and one lie. So two of those are triangles, one is not. And you can sort of have some good discussions. This is just an example, but we heard some good maths language there. We heard words like closed. We heard words like open shape. We heard words like polygon. Some students, it'll reveal a misconception, so an error in their thinking. A student might perhaps say something like, it's B because B's upside down. I've heard that before. So that's something that then becomes a teaching point, perhaps. I've heard A as the answer because they've just sort of said it doesn't really look like a triangle. They're expecting it more to be sort of that equal shape. So again, that's a nice little activity. Two truths, one lie. You could do anything with that. Again, that one is not mine. You can Google that, two truths, one lie. There's a gentleman who does mash up maths, MASH mash up maths, and he's got a whole booklet of these, so they're really useful at just getting students talking about mathematics, maybe revealing misconceptions and having a conversation around those. We use those a bit. Again, this one's a good one. There is an answer for this one, so have a go at that one if you like. What we're looking for there is just a little bit of fun. It's a fluency type activity, but again, we can have that reasoning brought into it. So the first thing the children might do is realize, hey, a pink jelly bean and a pink jelly bean is 4. Maybe the pink jelly beans are 2. So they can talk about, and you'd say, okay, why do you think that? And they might talk about the fact that 2 is half of 4. And so we can start to see some maths language happening there.
Yes, like I can see many 11s in the chat box.
Sure. Yep.
Yeah.
So again, our role there becomes talking to the students about why do they think that's the answer? How did they get to that answer? So those types of things. That one again is fairly easily found on the internet. That one's just
one has
called,
mentioned 3 plus 6 plus 2. I can see that
sure.
here.
Yeah, good. Excellent. Yep.
5 plus 2 plus 4 is also there.
Yep. And so rather than just putting it up on the board and just sort of saying, there you go, do it quietly, we can sort of get students that maybe even they could work in pairs, they can work in a small group, then they can come back to the class. It's not a race. There's no races in these. It's not who's first. It's about the mathematical language and how we can actually prove our answer to the class. So, even if you're trying to help, if you're talking to year 5 students, they might be trying to help a younger student try and understand it. Can they put it in mathematical words so that someone younger than them can understand it? So that's a nice little activity. Another little maths activity, again, a warm-up, is these types of ones. So they're just called a mystery, an Esther mystery. What I like about these ones is that you can do these just with materials at home. So it's got some little statements there. Feel free to work down that if you like. It's got some hints there, but we may not get time to completely solve this one. But just to talk about how you could use this in your classroom, you can take a photo of anything at all, really, and give the students hints about what's happening in that box or what's happening in that glass or anything like that. It's going to be really powerful if you use that in something that they've seen in their classroom. So rather than just taking a picture off the internet, if you could look at it and think about, okay, how could we use this from materials that we've got in our class? We live in a fortunate age. We've all got one of these in our mobile phones, smartphones generally in our pocket, which means that we've got a camera in our pocket. So we can have, as teachers, we can take photos of things out when we're shopping. We can use that and bring that into the classroom. We can talk about things that we're doing while we're out and about. As I said, the classroom is quite artificial, and our job is to try and bring the real world into there. So anything that we can do, taking a photo, maybe it might be even a discussion around, you might buy something at the shops and it might be 2 for this price and 1 for this price, and the students have to think about which is the better price, or think about, mystery might be which one you bought. So anything that you're taking a photo of that encourages students to communicate and use those reasoning skills that the National Curriculum Framework talks about. Another activity that we spoke about in that weekly timetable, suggested weekly timetable, is an open-ended question. Now, an open-ended question is one where there's multiple answers. So I'll say it again, one where there's multiple answers. Most classes, and in particular most textbooks, just give closed questions. So for example, 7 giraffes are eating leaves, 3 more come to join them. How many giraffes now? So if we put this question on the board, lots of us might think it's problem solving. It's probably really not. It's basically a fluency question. It's basically just asking the students 7 and 3. They don't really need to know what a giraffe is. They don't need to know much about them or any of the language. They don't need to care that they're eating leaves. It's basically just saying, if you know 7 and 3, well, the answer is going to be 10. Once one student puts a hand up and says 10, the question's finished. So there's not so much power in these questions. What we're after is an open-ended question. So you can actually do these yourselves. If you've got a textbook and you see these types of questions, by just changing a couple of words. So for example, I've done it below. We can change it to 7 giraffes are eating leaves. Some more join them. How many giraffes could there be now? I'm happy to take answers for that in the chat box as well, Tanisha, if people want to think about possible answers to that. Again, there's going to be multiple answers to this one.
Yes, I can see 7 plus x, x plus 7 is there.
Yep,
Then
so if we could
has
turn that
mentioned
into some
many.
numbers. Yep, yeah, sure. So, I mean, we could even look for
Someone
specific
has mentioned
answers
7
from
plus
students.
n, right?
Sorry, what's that one?
7 plus n, and total of 7, any numbers more than 7. I can see
Sure.
so many answers here. Yeah.
So what I should clarify is we're after explicit answers to this, even though there's multiple. So an example might be a student who's just starting out in mathematics might say 7 and 1 more came to join, and now there's 8. So they're showing us that they understand 7 and 1. A student in a higher grade might decide 7 and 3, and they're showing that that equals 10. So they might do 7 and 3 more came Mr. Hansen. Now there's 10. For students who are trying to show us in the younger grades, they might be showing us that they know the number to 100. So they might say, oh, there's 7 giraffes, Mr. Hansen, and then 93 came along. And now there's 100. So it's their chance to show us what they know about mathematics. Again, you can change that one up a fair bit, but basically you've got the chance with any closed question in a maths textbook or something similar to think about, rather than just giving a question where there's only one answer, where only one student answers and the rest of the class just kind of sits there, or they just wait for the other child to answer. We can give open questions. The power of it also is that the question lasts longer. A child might say 7 and 3 equals 10, and you could say, oh, good answer, but guess what? There was more than 3 that came along. And so then the child sort of thinks, oh, okay, well, I've got one right answer. They go back and try another one. So you can keep sort of changing it up depending on how they're going with that. Again, they could work with a partner. They could draw the answers. They could do a whole lot of stuff. So it's not so much trying to work out the exact answer or the algebra behind it. It's more about getting students just to practice and play with numbers in a friendly, safe environment. So you could adjust that depending on what grade you're in, of course. You might have something about in the upper grades about fractions. And it might be, I ate a quarter of a pizza. How much did I start with and how much, there's a quarter of a pizza left. How much did I start with and how much did I eat? And a child just starting out might say, oh, there was a whole pizza and he ate 3/4. Or then a child might start to play with multiple whole numbers and say, oh, there's 3 pizzas and he ate 2 3/4 or whatever it might be. So there's a whole lot of stuff that you can do with open-ended questions. They're quite powerful and I really like them for the discussion that they generate. All right, this is one that I like to use every single day. So this one is called a number talk. So the answer to this is 95. Okay, so you can even just tell the students the answer sometimes. And what we're interested here is not what the answer is, but again, we're interested in how did they work it out? So what I do here is I put the question on the board. That little picture there, that wheel, is just for us. It's not for the students, but I'll go through those. It just says that our job is to create a safe classroom environment. It's my job to be a recorder and a facilitator. I don't give the answer for how we should solve it. Sometimes I don't give the answer like I just did. Sometimes I do. We want to use it regularly. And the emphasis is on mental work and efficiency. So how can we get to the answer quickly? We want students to be able to develop their mathematical language and strategies. So if you like, in the chat box, feel free to answer how you would solve that if you didn't have pen and paper in front of you, please.
I can see 95. Someone has mentioned 200 minus 52 equals to 195. Someone has mentioned bracket 20 minus 1 into 5. Someone has mentioned 10 into 5 plus 9 into 5. And so many 95s are there. 45 plus 50, 100 minus 5. 5 into bracket 10 plus 9, bracket closed. Box method 20 into 5 minus 5. Box method again.
Yep, excellent. Yeah. So it's interesting, like, and again, with the box method, can we do that in our head? So what we're after with this one is, can we solve it in our mind? And we're trying to be flexible with how we use numbers. I understand some people went, like you said, 5 into 10, 5 into 9, put them together in their head. Great way. Excellent. Some people were flexible enough to think 19, that's close to 20. I can do 20 times into 5 and then take away the 5 and get to 95. So we're trying to get students to think about how they solve it. I've seen some students need a pen and paper for this. It might even be a student who's having some trouble doing lots and lots of dots, 19 dots, 19 dots, 19 dots, and doing 5 lots of them and then counting them up. You can then talk about with your class in a nice, safe way, in a nice, safe environment, what was the best way to solve that? And get the class to think about which way they think was the best. Obviously, it wouldn't be the one where we're just drawing the dots. We don't want the one where we've just given the answer 95. We're interested in how can we solve it with our language and using our words, because as I said, that national curriculum framework in India is calling for those types of things as well, both oral and written. So that ability to talk through your answers, to say, sir or ma'am, 5 times 19, I would do this for this reason. I understand that this is this. And then you get an idea as the teacher how comfortable they are with numbers, that they can trust 5 into 10 and 5 into 9 when put back together will give 95. Or like I said, the 20 and the 5 put together, take away the 5, we'll get back to that 95 as well. So again, that's just one example of a number talk. You could do so much with that. No matter what grade you teach, you might be teaching really young students. You could just put something on the board like, 6 plus 7. And students might put their hand up or talk to a friend about how 7 plus 6 is 7 and a 3 and a 3. So 7 get to 10, get to 13. Or they might see it as 6 and 6 is 12 and 1 more is 13. Or they might see it as 7 and 7 is 14. Take away 1 is 13. So even the most basic sums have so many ways to do it. And with these number talks, we're not telling students how we solve it. We're getting students to think about how they would solve it. And then we're validating their efforts because, again, mental maths is kind of an independent activity. As long as I get the answer and I get the answer consistently right and I get it fairly quickly, then that's what we're after for those number talks. Now, we mentioned one a little bit similar to this at the start. So this one, it's just an example of something that we might see at the shops. We spoke about the fact that we have a phone in our back pocket and we can take photos of things that we see. This is just to give you a further example of that. So when we're shopping, we might see this. This is McDonald's chicken nuggets. And at this restaurant, they were sold in packs of 9, 6, and 20. And you basically don't even ask a question for these for this activity. You get the students to think about the sorts of questions that they would be interested in. So it's a real shift in how we teach. It's not necessarily putting a question on the board. It's about getting the students to think about how that could occur. So what we do first of all is talk about, and this is an activity by Dr. Dan Meyer in the US with a lot of research behind it and a lot of weight behind it. Feel free to Google 3ACT, which is 3ACT, Dan Meyer. There's a whole YouTube and a whole lot of stuff about him and these 3ACTs are available. This is one example. So for really young students or for students who are struggling in our class, and this is part of that differentiation and making sure every child is included, we might do something like say, they might look at how much it would or how many packets we'd need to get 12 nuggets. And they might do a 6 and a 6. They could draw that down, maybe write that, do the sum for that, work through that. When they get the hang of that, they might find out what it would be or how many nuggets it would be if we bought the 6 and the 9 pack. And these seem like fairly low level questions, but we can easily raise that to questions that are even tough for us. So going up, we could think about, is it possible to buy 21? Have a go at that in the chat box if you like. Is it possible to buy 21 nuggets?
I can see 12 plus 9, 9 plus 6 plus 6. Someone has mentioned yes, someone has mentioned no.
Yep.
12 plus 9, yes, 12 plus 9, 9 plus 6,
Yeah.
4 into 5, 9 plus 7 plus 8. 2 boxes of 6 and 1 box of 9. So yeah.
Yeah, perfect. So that's that. Thank you, Tanisha. So that's the answer that we're sort of looking for with that question. A 9 and 2 6 boxes, and then students can work out a 9 and 6 and 6 is the same as 6 and 6 and 9 or 6 and 9 and 6. Again, we could make it even tougher. We could say, what's the biggest number? This is for those real mathematicians in the room. It's called a Frobenius number. That's the largest number that you can't make with given numbers. So we can make 21. Then the next question becomes, can we make 22? Can we make 23? Can we make 24? I wonder what the biggest number is that we can't buy. So when we take photos of things in the shops, it's a great chance to show the sort of maths that can work with that. For students who are really succeeding, we could even bring in money. You could say, what's the cheapest way to buy, 100 nuggets or more, those types of things. So yeah, I encourage you just to take some photos when you're out and about, or draw up pictures in your classroom of different prices and different things, and getting students to explore and work with that is always time well spent. When Dan Meyer is talking about these, he's basically saying on the left of these problems, in classrooms, we might have a lack of initiative, a lack of perseverance, a lack of retention. So students don't remember what they're doing the next day, an aversion to word problems. They're afraid of maths, and an eagerness just to solve something quickly and just to be basically parroting back what we've taught them. And his solutions are some of the ones that I've talked about. So use multimedia, encourage students' intuition, so getting them to think about what the answers could be, asking short questions like we've done this afternoon, asking questions like, what can you see? Or how many would this be? Let students build the problem. That's what we were talking about with that nugget question there, getting them to think about what they would like to look at. And this one's a really interesting one, 0.5, be less helpful. It sounds kind of weird as a teacher. We want to help them. We want to help them so much. Sometimes that help means that all the cognitive load, all the real thinking rests with us. It doesn't necessarily rest with the child. And for real learning and real knowledge to occur, particularly the type of learning that means that they can apply it to something else, means that they need to be doing the thinking. Because if we then give them a question that's slightly different, if they haven't done the thinking for the first one, they're not going to be able to apply it to the next one. So we want them to be doing the thinking. This is just some research around using objects in the classroom and going and using symbols and things like that in classrooms. Sometimes in classrooms, up the top of the triangle there, we use symbols like addition, subtraction, multiplication, division, and those types of things, maybe too quickly in some classrooms. Particularly students who are struggling need to actually handle mathematics. So they need to be holding blocks, they need to be rolling dice, they need to be using familiar equipment. Sometimes we think, students shouldn't be using fingers, we shouldn't be using those types of things, and that they should just do it pen and paper. And the research would say that for a lot of students, that's very abstract, and students have trouble with that sometimes. So just being aware, I guess this slide is just saying, just be aware of the need for students to still handle concrete manipulatives. I mean, if you think about it, like if I was going to learn guitar, I want to hold a guitar. It's no point in talking to me about, where my fingers should go and me not being able to hold it. So a bit the same with mathematics. We want students to hold the maths, to be handling the mathematics of its questions about, which animal, how many legs there might be on a certain amount of animals, that the students can actually hold little characters that have that amount of legs as an example, is always useful in our classrooms. So these are the sort of materials that we're talking about, rolling dice, using playing cards, using Unifix cubes, those types of things to let students handle the maths, that they trust the maths, that they know what that is. I'm just going to go through the next couple of slides fairly quickly so we can pass back to Tanisha. I hope the session's been good for you. Working with parents. This works courtesy of Joe Bowler, as it says down there in the bottom right credits. I'm happy to send these whole PowerPoints to you, or you can re-look at this and sort of have a think about which slides were useful for you. But basically, she's got 6 tips there for parents. So, and for you working with parents, it's really important that parents understand how your maths classrooms operate. It's going to be no good if you're teaching students how to solve questions one way, and then they go home and their parents just show them a totally different way and says, oh, don't solve it like that. We've got to do it like this. So working with your parents is really good. Number 3 there says we don't want to be associating maths with speed. So there's a lot of research into that our thinking basically gets shut down any time there's a timer on for students. So we don't want to be saying, okay, you've got 10 seconds to do these or whatever. So yeah, we want to be encouraging number sense, that number 5. That was similar to that number talks that I shared earlier. And as number 6 says, that's a really important one around growth mindset. We want students to be thinking that they can get better. Basically, we've found that if we tell a student that they can be good at maths, then they will be. Likewise, if a parent or a teacher says things, oh, you're not so good at maths, or you'll never be good at maths, it's very hard for that child then to see themselves as a mathematician. And we believe that all students can be mathematicians. They can all learn given the right environment and the right teaching. This one, like I said, I'm happy to send these slides to you, but it's just some useful free resources and activities to use in your classrooms. There's some of those we've had a look at today. So we've talked about 3X. We've talked about ones like Mashup Maths. We've talked about which one doesn't belong. So we've talked about a few different ones like those. They're free little activities that you can click on once you receive these slides. Okay, a humble plug here. The middle book and the right book there on the right there, sorry, are 2 books that I've published internationally, not for profit, with TBR books. So the one in the middle is all about mathematical mindsets, and there's one of those characters is really slow at maths, so thinks they're not very good at maths. Another student there thinks, oh, because they're a girl, they can't be good at maths, and that's of course not correct. And I like that the Indian National Curriculum Framework actually references that and says that girls obviously can be as good as mathematics. Orchestrating discussions is a really good little activity as well that you can have a read through by some authors called Smiths and Stein, and how to basically facilitate some of the discussions that we've spoken about in our classrooms today. And on the right, my book, My Garden is a Square, is an introduction to numbers 0 to 10 for students in very young grades. And it's got some manipulatives that you can purchase with those. So feel free to have a look at those. And so I'll close by today by just saying thank you to Tanisha and everyone involved in this conference and this presentation, and for hosting the conference as a whole. Tanisha, thank you very much for the opportunity, and amazing to have so many participants online. Thank you to the participants for answering back in the chat box as much as possible and for making it as interactive as possible. And I'm happy to keep in touch. And thank you so much for having me. Over to you, Tanisha.
Thank you so much, Mark. It was a lovely session. Participants, we have pasted the links of both the books in the chat box. Math for All and My Garden is a Square, both English and Hindi version. So if you want, you can purchase it from the links. Also, if we have any questions, you can mention it in the chat box. Okay, as of now, there are so many appreciation messages in the chat box.
Thank you, Tanisha.
That's great, really enriching. Thank you, thank you. I guess there are no questions, just the good messages and positive messages for you and for your session. So I think it's time. So yeah, on behalf of the entire team of Eschant, Mark, I would like to extend a heartfelt thanks for your enlightening presentation on what could a math week look like. Your expertise and insights were invaluable to our educators, and we are grateful for your time and your dedication. Your creative and innovative ideas were impressive for making math more engaging and relevant. And we would also like to thank all the participants for joining us today. We hope you found this session both enlightening and beneficial. And yeah, before we move on to the most awaited part of the summit, the quiz, I would like to say a few words for our speakers and participants. As the curtains close on a phenomenal chapter, we stand in awe of your exceptional dedication and invaluable contributions that have made Mathematics Summit 2.0 a monumental success. We are grateful for your passion for math and your commitment to making it accessible and enjoyable for everyone. We hope that you will join us again next year for Mathematics Summit 3.0. With deep appreciation, Team Eschan Publishing School Education recognizes and celebrates your incredible efforts, making Mathematics Summit an event and a landmark in the journey of mathematical enlightenment. Thank you so much. Thank you so much, Mark. So now let's move on to the Mathematics Summit quiz. I know you all are excitedly waiting for it. So we have pasted the quiz link in the chat box. So participants, please note that the quiz link will be active till 11:59 p.m. tomorrow, that is 27th August 2023. And we have also pasted the YouTube links for all these sessions in the chat box itself. So if you want to revise your concepts for these sessions, you can go through those sessions once again. So yeah, please copy the link and submit the quiz. Mark, if you want to leave, you may, for sure. Thank you for your session, Mark. It was really an amazing session. Thanks a lot. Participants' feedback form will be sent to your registered email IDs. And after that, after submitting the feedback, you will get your e-certificates. And it will be sent to you after this session. Just click on the link. If you are unable to copy the link, just click on it and it will redirect to you to that quiz. And from there, you can copy the link. Sessions are available on YouTube. I have shared the YouTube links in the chat box. If you want me to share it again, I'll do that. Want to leave the session, you can. I just hope you have copied the Google Form link. Yes, the feedback form will come in the mail. You can visit our YouTube channel, Chand Academy, if you want to watch the sessions again. All these sessions are mentioned there. You just have to search for Chand Mathematics Summit 2.0. If you are unable to copy the link, just select the link. That is, just click on it. It will take you to the quiz, and from there you can copy it, right? Participants, if you are unable to copy the link, just click on it and it will take you to the quiz page, the Google Form page. From there, you can copy it. Yes, session 1 was not there on the YouTube, so that is why you cannot find it there.
quiz link, na?
If you will click on the link, you will see the rules and you have to scroll it down. There you have to enter your information. Click on the next page, it will take you to the questions. This is how the Google form works. The rules are there so that you can understand how you have to attempt this particular quiz. Then you have to put in your name, your mobile number, your email ID. This information is required so that we can contact you in case you are the winner of the quiz. So do fill those information, then attempt the quiz. Session 1 was not live on YouTube. That is why you cannot find it there. But rest of the sessions are available on YouTube. We have pasted the link in the chat box. You can copy the link from there, or you can visit our YouTube channel, S-Chand Academy. There also you can search S-Chand's Mathematics Quiz and you can find the links there. And again, to attempt the quiz, just click on the link we have shared. It will take you to the Google form. From there, you can copy the link, or if you are trying to attempt it, just go through the rules which are mentioned there, enter your information, and then attempt the quiz. The information is required in case you are the winner so that we can contact you. So do fill that information. Thank you, Mark, for your kind words. And if you want to leave the session, you may, because we'll be live for like 5 more minutes so that the participants can access the quiz. Participants, you'll get the feedback form. Yes, you will get the e-certificates. And to receive the e-certificates, you have to fill the feedback. And after submitting it, you will get the e-certificates in your mailbox. So I guess now we'll be ending the session. I hope all of you have copied the link. I'm sharing the link for the last time. And yeah, thank you everyone. You'll get the feedback form on your registered email IDs, and after you will submit the feedback, you will get your e-certificates in your mailbox automatically. So do fill the feedback form to receive the e-certificates, and yeah, do submit the quiz. You never know, you can be the lucky winner. So yeah, thank you everyone. Take care. Have a great evening.